As humans, we have learned to represent numbers in the decimal system. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As we just learned, computers represent all information in bits. Here's what it looks like when a computer counts to 10. When you learn to count, you might have learned that the rightmost digit is the ones place, the next is the tens place, the next is the hundreds place, etc. Another way to say that is that the digit in the rightmost position is multiplied by 1, the digit 1 place to its left is multiplied by 10, and the digit 2 places to its left is multiplied by 100. It is all about place value. When we write numbers, the position, or place, of each digit is important. As we move left, each position is 10 times bigger. Tens are 10 times bigger than ones. Hundreds are 10 times bigger than tens. And as we move right, each position is 10 times smaller. From hundreds, to tens, to ones. When we multiply each digit by its place, we can see that 327 is equal to 3 times 100 plus 2 times 10 plus 7 times 1 equals 327. The binary system works the same way as decimal. The only difference is that instead of multiplying the digit by a power of 10, we multiply it by a power of 2. We start at 0, then we count 1, 2, 3, 4, 5, 6, 7, 8 and then 9. This is the last digit in decimal. We start back at 0 again, but add 1 on the left. 99. When we run out of digits, we start back at 0 again, but add 1 on the left. A binary number is made up of only 0 and 1. There is no 2, 3, 4, 5, 6, 7, 8 or 9 in binary. We start at 0, then 1. Now start back at 0 again, but add 1 on the left. One more. Start back at 0 again, and add 1 to the number on the left. But that number is already at 1, so it also goes back to 0. And 1 is added to the next position on the left. Start back at 0 again. For all 3 digits, add 1 on the left.